Hello, my name is Basab and I'm applying for the Fellowship.ai Cohort 33. So for this, I'm solving the NLP challenge that we have been provided here. So basically performing sentiment analysis on the IMDB dataset that we have. So let's just get started. But before that, I would like to say that I am applying for this because I want to learn more about machine learning and AI and gain some hands-on experience from industry experts. And I believe this would be a wonderful opportunity for me. But without any further ado, let's just get started. So first things first, I've just set up my Kaggle API key over here. So I've uploaded my JSON file. You can see I've uploaded it over here. I'm not going to do it again. But anyways, after I uploaded that, it just enables me to download our dataset from Kaggle directly into the session. So I've downloaded it in this code cell. Right, so basically just downloaded it. And this is where our core part begins. And by the way, I built this whole sentiment analysis pipeline to analyze the given dataset using both a traditional machine learning and a modern transformer-based approach. So let's just dive right into the core part of how things work. So here I've imported some necessary libraries. So pandas obviously here is for data manipulation. Then we've got regular expressions and spaCy. So this is for natural language processing. So basically tokenization. And then we've got scikit-learn. So here I've imported important parts. So train test split and TF-ID vectorizer. This is for some visualization later that we're going to do with. And then we've got logistic regression because I've trained a logistic regression model for this sentiment analysis. And then we've imported confusion matrix and classification report. And I've also used Seaborn and matplotlib. This is basically for dataset visualization. I've got transformers, obviously, for the more transformer-based approach where you're doing it via, this is like a Hugging Face library, so I've imported pipeline from it. And I've used TQDM. This is just like a very small part to show like a progress bar. This is just more convenient that way to just see this kind of progress bar. And I've strictly defined that we're using GPU and filtering any warnings during execution so that our outputs are more readable. So here in the next code block, I've specified a data path to download our dataset. And then I've created this function, a load data function. So what this does is basically download the dataset and then provides basic information about its shape and the class distribution, and also uses df.head. So it's basically outputting the first few rows of our dataset. So you can see when this is called, we get something like this. So our dataset, so it says the dataset set shape is 50,002. So which means our dataset has 50,000 rows and 2 columns. So which, when fetched from df.head, we can see 2 of those columns is review and sentiment. So one column is review, the other one is sentiment, and we've got 50,000 rows with the data itself. And similarly, the class distribution shows us that from sentiments, out of the sentiments, which are either positive or negative, 25,000 of those rows are positive reviews, whereas 25,000 of the rows from our 50,000 rows are negative reviews. So it's half and half for both. So after just inspecting our dataset, I've moved on to pre-processing it. So this is where spaCy and regular expressions come in. So we're basically doing the preliminary steps of NLP. So lemmatization, tokenization, lexical analysis, all that stuff. So the first thing we're done is cleaning our text. So what this does is remove any HTML tags and the non-alphabetic characters as it's specified in the comment that I wrote. And the reason we're doing that is because, as we can see, some of the rows, they have HTML tags like break, and it also has apostrophes or inverted commas, and it's just best practice to remove those when we're creating tokens. And we've used spaCy over here for lemmatization. You can see we've used for pre-processing the reviews and also filtering out any stop words and non-alphabetic tokens. And after that, I've used a plot review function. So it's basically done for visualizing the distribution of our review lengths across different sentiments in the dataset, and I've done this using Seaborn. So this basically gives us an output like this, right? So we can see that the box plot, the sentiment box plot, it distributes the distribution of review length by sentiment, so either positive or negative. And we can see that both of these have like a similar patterns with outliers, right? With the positive having more outliers, so it's got like more reviews. It's got some reviews that have over 2,000 characters in length. Moving on, we have the core machine learning part, I believe, after this. Yeah, we've got the train and evaluate section. So what I've done here is basically train our core regression model using logistic regression, so using scikit and TF-ID vectorizer. So this core ML part, what this does is uses a TF-ID vectorizer as specified over here with the logistic regression. So I vectorized all of the text data, so like max features were 50,000, so I used vectorized the data using n-grams with the range of 1 and 2. So the lower is 1 and the upper is 2 range. And then I evaluate the model using classification report and then confusion matrices. So since this has come up, so a confusion matrix is like a matrix that summarizes the performance of a machine learning model on a set of, say, test data. So it's basically like a tool or a means of displaying the model of accurate and inaccurate, the number of accurate and inaccurate instances based on the model's predictions. And we often use this to measure the performance of classification model, which aim to predict categorical label for, say, each input instance. So this matrix, basically the confusion matrix, it basically displays the number of instances that the model produces on the test data, right? So after creating the whole model, the logistic regression model, oh, and by the way, it also generates a heat map. So this is where our confusion matrix is visualized after evaluation, right? So after we train it on our dataset, the train split data set, we evaluate our model, right? So it predicts on the test dataset, and then it produces a classification report, as you can see, and then generates a heat map. So I've visualized it using Seaborn. So it just generates a heat map of our confusion matrix. It's going to be really cool. I'm going to show it to you guys in a while. And here in this code block, sorry, I've used a modern approach. So I've used a Hugging Face transformer library to show how pre-trained model can be used for sentiment analysis. It's just used, it's like a comparison point with our traditional approach, because using a regression model is more or less a traditional approach for something like sentiment analysis, right? And this is like the easy way out. So we can just use a sentiment analysis pipeline from Hugging Face and directly do it, the sentiment analysis, right? So here what happens in this with the sentiment analysis using the Hugging Face transformer is I select a transformer pipeline. So here we're using a distilled BERT. So it's like a distilled BERT, a very lightweight compressed version of BERT. And then we provide a sample review. So I wrote this review, which we can distinguish was has a positive sentiment, right? So I've basically just specified that this movie was absolutely fantastic, the acting was superb, and the storyline kept me engaged throughout, and definitely worth watching. So we as humans, we can determine that this is a positive review, but for a model to determine whether it's a positive or negative review, it has to go through iterative processes of analyzing various data sets or like various rows in our data to compare it with, and then determine whether if it has a positive or negative sentiment. So now the result of this is basically it prints a sample prediction. So prints a title first, and then we're printing the text. So first we're printing what we provided over here, and then it prints the sentiment, so it gives us the result. And by the way, the device 0 over here is just implying that we used the GPU. And then, so here the result is 0 means that we're labeling, we're basically labeling our data, the sentiments based off of keywords. So like the top positive word has basically like the words with high positive coefficients, whereas the top negative words are the words with the negative coefficients, right? So when we do this, it just basically gives us the whole sentiment analysis in a very simplified manner. So now here we have the main pipeline. So here we basically just orchestrate all of the functions that we've created, right? So first of all, I load the dataset over here using the data path that I specified right here in the session. And afterwards, we're initializing spaCy, so we're loading our spaCy model for NLP, so basically tokenizing everything, and then we use the preprocess review function to preprocess all of our reviews. So tokenize everything, remove any stop words and all that stuff. And then here we plot our distribution data, so we're visualizing that. And I believe I showed I showed this graph before, just to visualize our review lengths by sentiment. And then afterwards we prep our data set. So here we are just splitting our data set into train and test splits. So what I've done here is I've set the test size to 0.2. So what this means is out of the 50,000 rows that we have, we're setting apart 20% of that as a test data, and 80% of that is set up as a train data subset for our model. So we're basically using 80% of 50,000 rows to train our model, and then we're using the remaining 20% to test our model based off of that, to see how accurately it guesses the sentiments of the dataset, right? And the TF-ID vectorizer, what it does is like we're just doing text reviews using the TF-IDF. So it's like term frequency inverse document frequency, right? So it does it by bigrams or unigrams. So in our case, when we use TF-ID vectorizer over here, the max features mean that the vocabulary is limited to 50,000 features, just for efficiency. I just forgot to explain that. It just came to my mind, so it's better to just go back to it. But anyways, when we prep our data, then we initialize our model over here. So then the model makes predictions on the test set, and then it calculates evaluation metrics. So these are usually like the precision and then the recall and the F1 score, where like the precision basically means like the proportion of true positive among the predictive positive, and the recall is like proportion of true positive among, say, the actual positive that we have, and the F1 score is basically like the harmonic mean of precision and recall. And if we go back to our regression model, we can see that it shows us all of that, and then it also visualizes a confusion matrix, as I said, right? So it generates a heat map to show the confusion matrix. So let's move on to the output. So like when we call the model, so we can see it vectorizes the training data, and after completing that, it trains our logistic regression model, and after that is completed, it produces a classification report. So what we can see from the output over here is that the overall accuracy in our model is 0.90, which means 90% of overall accuracy, which is extremely good, right? And there's like balanced performance across both sentiments, so we can see from the recall and F1 score. And moving on, we have like a heat map generated from the confusion matrix, right? So we can see that from this confusion matrix plot, the true positive and the true negatives are significantly higher than the miscalculations over here. Where like the true positives, so like 44,000 and 15 is like the positive sentiment, and 4618 are like the negative sentiments. And our predictions have been very high for the true positive and the true negative. So it means our model has categorized sentiments accurately for like positive and negative. So like this many has been done right. So like 44,015 and 4,415 and 4,618 are like positive and negative sentiments that our model categorized correctly, whereas 421 and 546 of those were misclassified. But this is pretty much a very good accuracy, because as we can see, we had an accuracy of 90%, which is actually pretty good, right? And for our Hugging Face model approach, we didn't really specify a model, so it just basically defaults to a Dilbert, right? So it defaults to this exact model. So for that, when we supply this text, which is our test data, it gives us that the sentiment was positive, and it gives us a confidence, where this confidence means how much it's sure that the data was either good or bad. So according to the transformer model, this review was a positive sentiment review, and it's very sure because it's also trained similarly, but it's trained differently, but yeah. And yeah, so that was it, guys. So we basically, I did the sentiment analysis over here using a regression model, which gives us a very high accuracy, by the way, 0.9, impressive, I would say. And also did it with a Hugging Face transformer architecture. And that's that, guys. Thank you.